Okay, in this video, I'll be covering the concepts of equidistance as well as to recap on the formula of a length of a line segment. So before I start into the worksheet examples first, let's do a simple recap. Okay, we have learned if I have 2 points like this, and I know the coordinates of these 2 points, I call them x1, y1 and x2, y2. The formula to find the length of this black color line that joins these 2 points together is given by the formula here, square root of, this one you must memorize, square root of x2 minus x1, the whole thing square, plus y2 minus y1, the whole thing square. Okay, this formula here you must remember. How do you find the length of a line segment? Okay, so now we are going to learn this new term called equidistance. What does equidistance mean? It just means same distance. So let me use some examples to illustrate this for you. If I say point A is equidistant from point B and C, it means that if I were to have these 2 points over here, okay, point B and C, point A lies at the point whereby it is the same distance from B and from C. Where do you think point A can lie? So imagine, right, if it must be the same distance, it means that point A must lie in between here, right? Point A, in between A and C. Do you agree? Over here, this distance here must be the same. Okay, this is what we can call equidistance. Okay, but you must think about it, right? Equidistance means, can point A lie, let's say, somewhere over here as well? I call this, can this also be point A? It is also possible because this distance here can also be the same. This distance over here can also be the same as from A to B. And what you can slowly realize is that as long as line A lies along this vertical line, at any point along this vertical line, it is equidistance from point B and from point C. Because no matter where your point A is, wherever you put your point A, the distance from point A to B is always the same as from point A to C. This is what we call the perpendicular bisector of line BC. Something that we have done before. So remember, point A just needs to lie anywhere along this line to be equidistant from point B and point C. Another simple example, let's say the question here says, point A lies on this line, and it is 5 units away from point B. Where do you think point A can be? 5 units away means that if I measure maybe 5 units away, it can be maybe if this length here is 5 units, okay? If this here is 5 units, this means that point A must lie over here, okay? But think about it, is this the only possible position of point A? 5 units, right? If I were to check, right, along this whole line here, if I move my point A to somewhere over here, I can also find another point on the left side of point B, such that it is also 5 units. Somewhere maybe about, somewhere here. Okay, this can also be 5 units, and this will also be a possible position of point A. Okay, so this is the concept of equidistance. Over here, point A is equidistant from point B because the distance between A and B is the same, 5 units. So there are different possible positions of point A. Okay, so I hope these examples illustrate to you what is the meaning of equidistance. Now let's look at the worksheet example. Let's now look at example 4. Okay, example 4 here says, the coordinate of point A is given by 2, 5, and point B lies on the x-axis such that AB is 13 units. Find the possible coordinates of point B. So if you find it hard to visualize, let's draw a simple diagram. I know that the x-axis is horizontal line, so let's imagine this as my x-axis. Okay, I will treat this line over here as my x-axis. I will draw this part out here using a horizontal line. This will be my x-axis. Okay, then over here, I know that point A is 2, 5. So maybe if I draw my vertical y-axis something like this, okay, this means that I can call this point A, which is 2, 5. Okay, from here, the question here says that B is somewhere along this x-axis such that A to B is 13 units. So if we follow a similar concept, B can lie either here or here, whereby this distance here, let's label, is 13 units. 13 units. This distance here, I draw arrow so that it's clearer, huh? Okay, this distance here is 13 units. This distance here can also be 13 units. Yeah, 13 units. Okay, therefore, this means that point B can be here, or point B can also be over here. Okay, and therefore, since they lie on this x-axis, I know that the coordinates is usually written as something comma something. Okay, since they lie on the x-axis, the x-axis all have different x values. But what do you think is the y value here? Okay, if you were to label my axis, right, this is 0. Do you notice that on the x-axis, your y coordinate is always 0? So that means that I know that my y coordinates here are always 0, since it lies on the x-axis, but I don't know what is the x coordinate over here. Okay, so over here I don't know what is this number. What are these numbers? I can just write over here. Let's say k comma 0. I don't know what is this number. I call this k. I want to find out what is the values for k. Let k comma 0 be the possible coordinates of point B. Possible coordinates of point B. Okay, then given by the question over here, I know that length AB is given by 13 units. So over here, I know the coordinates of A, which is this. I know the coordinates of B, which is this. By applying the length formula, I write the length formula again. Length formula is given by, to find length of any line segment, it is always x2 minus x1 square plus y2 minus y1 square. Okay, so therefore I can look at my A and B over here. I can call this point A my x1. I call point A x1 comma y1. Point B here I call this x2 comma y2. Okay, so therefore the length, I know that the length of AB is 13 units. So this means that length of AB is equal to square root of x2 minus x1, which is k minus 2 square plus 0 minus 5 square. This length here is equal to 13 units. Okay, therefore from here I just need to solve this equation now. Okay, let's look at this part here. To make our life easier, let's get rid of the square root. To get rid of square root, I'll square both sides of the equation. So this means that k minus 2 square plus, over here 0 minus 5 is just negative 5, the whole thing square, equals to 13 square. Because I square both sides of the equation to get rid of the square root, I'll get a square here. Okay, now I further simplify. I'll get k minus 2 square plus 25 equals to 13 square is 169. Okay, therefore this means that k minus 2 square is equal to 169 minus 25, which will give me 144. Okay, this means that k minus 2 square is equal to 144. Therefore, how to get rid of the square here? I take square root. Remember, in the square root unknown, it must be a plus minus. So k minus 2 is equal to plus minus square root of 144, which means that k minus 2 is equal to plus minus 12. Okay, so from here, now I can easily now find what is the value of k. Let me move this up a bit. Okay, this means that over here, k minus 2 is equal to positive 12, or k minus 2 is equal to negative 12, which means that k is equal to 12 plus 2, which is 14, or k is equal to negative 12 plus 2, which is negative 10. Okay, so therefore, I haven't answered the question yet. Question here says, find the possible coordinates of point B. Coordinates is always written in the form of bracket, x coordinate, comma, y coordinate. So therefore, answer the question. Last step from here, since I know that k can be two values, final answer. Therefore, possible coordinates are either k is 14, 0, or k is negative 10, 0. And these are your possible coordinates of point B. Okay, This is for example 4. Okay, now you can pause the video, try the next part by yourself first. You can spend about maybe 3 to 5 minutes to try this part here. Once done, you can continue playing this video to watch me work out this question. Okay. Alright, so now I'll move on for here. Okay, over here, I hope you have tried this before you watch this part, then you can really learn how to apply if you can understand what I've been talking about. Okay, now let's read this question here. Point C, given by this coordinate here, find the possible coordinates of point D that lies on the y-axis. So over here, let's draw the simple diagram. Y-axis is a vertical line, so I can treat this vertical line here as my y-axis. I'll label this clearly here. I treat this as my y-axis. Okay, maybe I call this point C. The coordinates is 3, 2. Okay, therefore it means my x-axis line should be somewhere like this over here. My x-axis. Okay, and then it means that point D lies somewhere on the y-axis such that C to point D is 5 units. So by this diagram here, it means that this distance here is 5 units. 5 units. Or this distance here is 5 units. Okay, 5 units. So over here, this can be point D, or this part here can be point D. Now you need to find what can point D be. Okay, if I were to analyze, right, for point D, what are the possible coordinates? Something comma something. I know that point D lies on the y-axis now. Okay, so over here, if you check your y-axis, right, on my y-axis, there are different y coordinate values. Okay, so therefore, the y value, I don't know. But I know one thing for sure. The x value. Anything on the y-axis here, the x value is 0. So this means that the x coordinate here is always 0. I don't know what is the y coordinate. So over here, I can let this unknown number be k. Okay, so that's just similar to the previous part. Alright. Let k comma 0, not k comma 0, but in this case it will be 0 comma k be the coordinates of point D. Okay, so same thing as just now, the length is given by the length CD here. I know the coordinates of point C and coordinates of point D as well. Okay, so therefore, by applying my length formula, square root of, I hope you still remember how to apply the length formula. Okay, over here, x2 minus x1. So this will be x2 CD. I call point C here my x1 comma y1. Point D here, I call this my x2 comma y2. Okay, so over here, by applying the length formula, x2 minus x1, 0 minus 3 the whole thing square, plus y2 minus y1, k minus 2 the whole thing square is equal to the length, which is 5 units. Okay, now I square both sides of the equation to get rid of the square root sign. I will get 0 minus 3 is negative 3 square plus k minus 2 square equals to 5 square. Okay, then I simplify it step by step. Negative 3 square is positive 9 plus k minus 2 the whole thing square equals to 25. Therefore, I get rid of the 9 on this side of the equation. K minus 2 square is equal to 25 minus 9, which means that k minus 2 square is equal to 16. Therefore, to find out what is k, I get rid of the square by square root both sides. Square root unknown, I should have a plus minus. K minus 2 is equal to plus minus square root 16, which means that k minus 2 is equal to plus minus 4. Okay, so therefore, k minus 2 is equal to positive 4, or k minus 2 is equal to negative 4. Therefore, k is equal to 6, or k is equal to, if you find it hard to visualize, negative 4 plus 2, which is k equals to negative 2. Okay, therefore, answer the question. Find the possible coordinates of point D. Therefore, possible coordinates means your final answer should be bracket something comma something. Possible coordinates is simply over here. I know that k can be 6 or negative 2, so it will be 0, 6 or 0, negative 2. Okay, and this is for this example here. Okay. Alright, so let's now look at part C here. Example 5 on the next page. Okay, example 5. Use length to show that a triangle is a right angle triangle. So over here, how do we visualize this question? Okay, if you find it hard, right, let's read this question here first. A triangle has vertices, means the 3 points, given by these coordinates, P, Q, R. Determine if it's a right angle triangle. Remember, so if you think about it, right, how do I know if a triangle is a right angle triangle or not? What you have learned before in lower sec is that right angle triangle will fulfill Pythagoras theorem. Okay, Pythagoras theorem. Okay, so over here, how do I check that? If you find it hard, let's do a simple sketch to visualize this. Okay, let's draw my simple x and y axis. Okay, y-x. Then I plot the points, okay, so I can visualize better. Point P, 2, 3. So let's say I plot the points, let's say 2, 4, 0. Then 1, 2, 3. Okay, 1, 2, 3. So over here, this means that point P somewhere over here. Okay, point Q somewhere over here, point Q. Then point R, -4, -1. So this means that point R is given by let me make this smaller. Oops. 0, -1, -2. Okay, so that means point R lies somewhere over here. Okay, so therefore, if I were to draw this as a triangle, this means that the triangle should look something like this. Okay. Oops. Okay, maybe my drawing is not the most accurate, but I want to show that this triangle here is a right angle triangle. So over here, we must check very carefully. Let me label point R lies over here. How do I show that this is a right angle triangle? Remember, Pythagoras theorem states that Pythagoras theorem, what does it mean? It means that for any right angle triangle, let's say I draw a triangle like this, okay, A, B, C, it must fulfill the equation A squared plus B squared equals to C squared, whereby C is the longest length of the triangle. So over here, very simply, let's find the square of all the sides of this triangle. We find out what is the square of this side, and this side. Okay, so over here I check. Let's try. Let's first find PQ square. Okay, PQ square. We use the formula here. Let me write out the coordinates so that we can remember more clearly. Okay, P is given by 2, 3. Q is given by 4, 1. Oops. 4, 1. And R is given by -4, -1. Okay, so first thing, by length formula, PQ square. Apply the length formula. It is simply x2 minus x1. 4 minus 2 the whole thing square plus 1 minus 3 the whole thing square. Okay, it simplified from here. PQ square don't need the square root. Sorry, this one should PQ square is simply by this. Okay, the length of PQ is given by the formula here. PQ, sorry, not PQ square, but PQ is given by this square root formula based on my length formula. Okay. Okay, this is our length formula if you still remember. Then I calculate this. Okay, PQ is simply equals to 4 minus 2 is 2 square plus -2 square, which will give me square root of 4 plus 4, which will give me root 8. Okay, next one. I find the next length. Based on this triangle, I can now find the length of RP. Okay, so RP over here, we follow the same steps. RP is given by square root of, square root of RP, so it will be 2 minus -4, the whole thing square, plus 3 minus, I put square bracket because there's a negative, 3 minus -1, the whole thing square. Okay, take note of the negative signs, don't make careless mistakes. We work it out step by step. Okay, RP, the length of RP is simply 2 minus negative 4. This will be 6 square plus 3 minus negative 1, 4 square. Okay, simplify further. This means this is 36 plus 16. I will get square root of 52. This is RP. Okay, so this means that this length here is root 8. This length here is root 52. Okay, and the last one over here, QR. QR equals to square root of, apply the length formula, QR. It is simply negative 4 minus 4 the whole thing square plus negative 1 minus 1 the whole thing square. Okay, I'll get square root of, this is negative 4 minus 4, negative 8 square plus negative 2 square, which will give me square root of 64 plus 4, and it will give me square root of 68. Okay, then now I observe this triangle. Okay, so now with this, I have found the length of all three sides of this triangle. So I write it very clearly here. All three sides of this triangle, I have found the length. Longest length is square root 68. So now how do I check if this is a right angle triangle? I must check if it fulfills Pythagoras theorem, whereby the square of the longer side is equal to the sum of the square of the two shorter sides. From this part here. Okay, so over here I know that the two shorter sides is RP and PQ. So let's check. Okay, RP or PQ square plus PR square. This is the sum of the two shorter sides is given by PQ square. PQ is root 8. PQ square is simply 8 plus RP or PR is root 52. So PR square is simply 52. And this is equal to 60. Okay, then QR square, the longer side, is simply equals to 68. And therefore, I note that since PQ square plus PR square, the sum of the two shorter sides of the triangle, is not equals to the square of the longer side of the triangle, therefore, this triangle PQR is not a right angle triangle. Okay, and this is how we solve this example 5. Okay, because the triangle does not fulfill Pythagoras theorem. Okay, so I hope that you can visualize how do we solve this question from here. Alright, let's now move on to the last two examples. Let's look at example 6. Very simply, given 3 points, show that AP is equal to BP. So very simply, apply your length formula. Okay, I write out the formula here again in case you have forgotten. I would like you to try this by yourself first before you watch this video. Very easy one, just apply the formula. X2 minus x1 square plus y2 minus y1 square. Okay, so over here, this is simply a length of AP is given by the formula here, square root of, okay, 3 minus negative 2 the whole thing square plus negative 4 minus 1 the whole thing square. Okay, I work out step by step. 3 minus negative 2, I'll get 5 square plus negative 5 square. This is simply square root of 25 plus 25, and this will give me square root 50. Okay, this is length of AP. Next part, length of BP. Same thing, apply the formula again. The formula is simply over here, 3 minus 4 square plus negative 4 minus 3 square, which will give me square root of 3 minus 4 is negative 1 square plus negative 7 square, which will give me square root of negative 1 square is 1 plus negative 7 square is 49, which gives me root 50. And I notice that the length are the same. Okay, therefore we can conclude that AP is equal to BP. Okay, this is an important conclusion that you must state based on the results we have shown over here. Okay, and this is for example 6. And it can include a shown, which is what the question wants you to show. Alright, Now, last question, example 7. The distance between the points is 5 units. Find the possible values of k. So they're telling me that the length here of between these 2 points is 5 units. So if I apply the formula, okay, square root of, I find the length between these 2 points. x2 minus x1, 1 minus negative 3, the whole thing square, plus k minus 2, the whole thing square. This should give me 5 units based on the question here. Okay, the length, or maybe I call it length. Length is simply 5 units, and the length is given by this formula here. Okay, therefore I simplify this, square both sides to get rid of the square root. This will give me, I simplify this as well. 1 minus negative 3 is 1 plus 3, which is 4 square, plus k minus 2 square. Square both sides, it will be 5 square. Okay, then from here, this will give me 16 plus k minus 2 square equals to 25. Okay, therefore from here, to find out what is k, I subtract 16 from both sides of the equation. I'll get k minus 2 square equals to 25 minus 16. Therefore, k minus 2 square is equal to 9. Okay, so from here, I want to find k. To get rid of the square, I will square root on both sides. K minus 2 is equal to plus minus root 9, which would mean that k minus 2 is equal to plus minus 3. Therefore, k minus 2 is equal to positive 3, or k minus 2 is equal to negative 3. Okay, therefore, k is equal to 3 plus 2, which is 5, or k is equal to negative 3 plus 2, which is equal to negative 1. Okay, and with that, we have found the 2 possible values for k. Okay, and with that, we are done with this worksheet. Okay, you can complete the homework questions from the workbook as well for this worksheet. Okay.